Let n belongs to natural number and Jn equal to 0 to pi by 2 cos nx dx. Which of the following statement are true? Jn is a rational for all n greater than equal to 2. Jn is a rational for all n greater than equal to 2. Jn is a rational if n equal to 7. So first come to the point, what is rational and irrational number. Rational number are those numbers whose decimal expansion either terminating or non-terminating but reoccurring. Decimal expansion have two decimal expansion format, either they are terminating or non-terminating but reoccurring, non-terminating and reoccurring. And irrational number are those decimal expansion whose decimal expansion is non-terminating and non-reoccurring. Non-terminating and non-reoccurring. This is the definition of rational, and last one is definition of irrational number. Also, irrational number having irrational number, some irrational number are pi, e, is within square root any prime number. For example, root 2, root 3, root 5. These are few irrational number. Now come to the question. Jn is defined as from 0 to pi by 2 cos raised to the power nx dx. You can resolve this cos nx into product of two functions. So this can be written as 0 to pi by 2 cos square x into cos raised to the power n minus 2 x dx, or 0 to pi by 2 cos x into cos n minus 1 x dx. I am using this one format to solve this problem. So Jn equal to 0 to pi by 2 cos x into cos n minus 1 x dx, and this is my first function and this is second function, and using integral by parts, according to integral by parts, I can write Jn equal to cos n minus 1 x into sin x minus n minus 1, and this integral is cos square x sin x into sin x, and limit is from 0 to pi by 2. This first term is same as, and this one is n minus 1 cos square x and sin square x, and I can use property of sin square x is 1 minus cos square x, and limit is from 0 to pi by 2. After applying distributive law in this term, I can write n minus 1 integral from cos square x minus cos n x dx, and limit is from 0 to pi by 2. So finally we have Jn equal to cos raised to the power n minus 1 x into sin x minus n minus 1, and integral 0 to pi by 2 cos n minus 2 x dx minus n minus 1 n minus 1, and it will be Jn. So you can take this Jn left hand side. So this one equal to jn 1 plus n minus 1, and this is equal to cos n minus 1 x into sin x minus n minus 1 j n minus 2, and this one equal to n jn equal to, also limit is from 0 to pi by 2. This is running from limit 0 to pi by 2. First term will go to 0 because of cos pi by 2 0, and at lower limit sin 0 is 0. So finally we have n minus 1 jn minus 2. So jn can be written as n minus 1 upon n jn minus 2. This is the expression I obtained. So finally I can write jn as n minus 1 upon n, n minus 3 upon n minus 2, and so on. This will be up to 1 upon 2 j naught when n is even, and this one equal to 2 by 3 j1 when n is odd. So finally you can observe at this stage our result is only depend on j naught and j1 if this is either this is rational or irrational. So first evaluate j naught. J naught can be evaluated as 0 to pi by 2 cos raised to the power 0 x dx, and this value is equal to pi by 2, and j1 is equal to 0 to pi by 2 cos x dx, and this value is equal to sin x. Sin x from 0 to pi by 2 will equal to 1. So finally we have jn as n minus 1 upon n, n minus 3 upon n minus 2, and so on. J naught was pi by 2, and j1 is 1. So this one you can observe this pattern. So this is containing pi by 2 when n is even number, and this is odd. So in odd case you can observe n minus 1 upon n, and n minus 3 upon n minus 2. All these are rational number. So in the case of n equal to 7, jn is rational. So this option is true. And for other option, rational and irrational for all, because of the term for all, we are obtaining irrational number in the case of even case also. So these two options are false.